Hello. In this video, we will be discussing in general how alkenes react to turn into other compounds. In other words, there are some reactions we'll be learning in this chapter in which a compound, which we call an alkene, because it happens to have a double bond in its molecules, can be converted to alcohols, alkyl halides, and a few other things that we'll see as we go along by reacting with various reagents. Now, of the 10 reactions that we'll be learning in this chapter, 9 of them are what we call addition reactions. In addition reaction, the carbon-carbon double bond is reacted with some reagent, which I've indicated as XY in this case. That's obviously just a generic symbol for some compound, or in some cases several compounds together, which will then result in the double bond disappearing and part of the XY molecule, whether it's a single atom or a group of atoms, adding onto one carbon, and the other part of the XY molecule, again, whether it's a single atom or a group of atoms, adding onto the other carbon of the double bond. So this is generally what we mean by an addition reaction. The double bond disappears, it becomes attached to one carbon, and something else becomes attached to the other carbon. Here is a list of the reactions we'll be learning in this chapter, and I present it here not because I want you to memorize it or anything like that, but just to give you a heads up about the reactions we'll be learning in this chapter, and also to notice some things. First of all, I've numbered them slightly weirdly here. 1 through 7 are the same as reactions 1 through 7 in the textbook. The next one is what the textbook is referring to as number 9. The next one I will cover is called epoxidation, and it's not even covered in the textbook in this chapter. It's covered in a later chapter, but I think it fits better into this chapter, so we'll be covering epoxidation. And finally, the last one I've listed here is number 8 in the textbook is the last one we'll be covering, because that one's different from all the other ones. This is the 10th reaction, which is not an addition. All the rest of these are addition reactions, and that's why I'm going to be covering this one last. A couple other things to notice here. Reaction number 5 is called oxymercuration demercuration, and it's going to involve a reagent that has mercury in it, followed by a separate addition of a reagent, in other words, a second reaction that's going to happen right in the same mixture, where we'll add another compound called sodium borohydride. So this is what's called a one-pot, two-step synthesis, because we'll be first adding mercury acetate in water, and then after that reaction is done, that's called oxymercuration, we'll be adding another reagent, sodium borohydride, and then a second reaction will occur right in the same flask, and the final result will be an alcohol. Hydroboration oxidation is a similar thing, where we'll first be adding BH3, and then after that reaction is done, called hydroboration, we'll be adding hydrogen peroxide and sodium hydroxide, and that's where the oxidation comes in. Again, don't worry about memorizing that yet for this video, but we will be talking about that specific reaction and all the rest of these specific reactions in later videos. Now, a couple things we need to know about when it comes to addition reactions to alkenes. One is which carbon gets which group. So you may have noticed when I outlined this for you before, the X attached to one carbon and the Y attached to the other carbon. Now, it doesn't make any difference which is which, as long as the groups that are attached to this end of the double bond are the same as the groups attached to this end of the double bond. Then it doesn't matter which carbon gets the X and which one gets the Y. In other words, these two would be the same thing as each other, but if the groups on the ends are different from each other, then it does matter which one gets the X and which one gets the Y, because then these two compounds are different, and it may be that we get both of them, or it may be that we get only one of these two, and we have to predict which one would we actually get, and that's what's called regiospecificity. In other words, you're specifying which region of the molecule gets the X and which region gets the Y, so that's why it's called regiospecificity. There are certain rules that we'll learn, and we'll understand why those rules work as well. Another thing we have to worry about when it comes to addition reactions is the stereospecificity. Again, notice that an alkene, because the carbons are sp2 hybridized, is flat, and I've drawn it, in this case, roughly parallel to the floor. And notice that the two groups, X and Y, can both add on the same face, in other words, both on the top, or both on the bottom, which would be the same thing, and that's called syn addition. Or the X could add to the top and the Y to the bottom, or vice versa, which would be the same thing, and that's called anti-addition. In some cases it matters, and so we will need to know and for most of these reactions, most of the 9 addition reactions, do the two groups add syn, or do they add anti, or both? In some cases both things happen at the same time. So which of those specific things happens is called stereospecificity. So reactions will either be syn, or they will be anti, or they will be non-specific, meaning both at the same time. And again, we will learn which reactions have syn addition, which ones have anti-addition, and which ones are non-specific, and why. Then let's talk a little bit about the 10th reaction. It's a degradation reaction, not an addition. In other words, it's a reaction in which you're literally going to break the double bond in half, and you'll get two new molecules, both of which, as it turns out, will have double bond O's on them. So these will, products of that reaction, by the way, it's called ozonolysis, and it's the last one on the list that I showed you a minute ago. The product is always ketones and or aldehydes. Finally, a word about mechanisms. Every reaction always has a mechanism. Many of them we will learn what the mechanisms are, but some reactions we don't really know what the mechanism is, and so obviously you're not going to have to learn the mechanism if chemists don't even know what it is. And some we do know what it is, but it's too complicated or involves steps that we're not prepared to deal with yet, so we will not learn those mechanisms. But in this particular chapter, 7 of the 10 reactions that are covered in this chapter, you will learn the mechanisms of. Some of them are very similar to each other, most of them are pretty simple, but you will have to know 7 mechanisms. That's the end of this video. Thank you.